Yes, welcome back to the second session of Green Building course. In the last video, I have been introduced to the course, what exactly you are going to people study in that particular course. I have been exposed to the word of green buildings. So moving on to in this particular session, the actual syllabus, that is module number 1, okay, where you can see in that module, module 1 deals with introduction to the concept of cost effective construction. So this is what the module number 1 deals with, introduction to the concept of cost effective construction. So as I stated in the last video, you are going to expose to the various types of materials. Okay, that is, the material can be classified into conventional material, that means your people are going to study the conventional materials, and also alternative materials where we can reach the sustainable environment or where we can execute the green building concepts. So moving on to the what exactly you are going to study in the module number 1. So these are the contents or materials you are going to study in the module number 1, that is, as I highlighted, different types of building materials or materials. That is, starting with stones, we are going to discuss laterite blocks, burnt bricks, hollow clay blocks, concrete blocks, stabilized mud blocks, LPC, that is lime pozzolana cement, gypsum boards, lightweight beams, fiber reinforced cement components, and fiber reinforced polymer composites or components, then likewise bamboo and so on. Okay. So as people can see from the slide, these stones, laterite blocks, burnt bricks, clay blocks, concrete blocks, all these are conventional materials. You can see over there. Stones, laterite blocks, burnt bricks, hollow clay, concrete blocks and stabilized mud blocks. All these blocks are, okay, that is conventional materials. And coming to the alternative materials is stabilized mud block, which is a best alternative to the clay bricks, or I can say the clay blocks or burnt bricks. Next, LPC, that is a lime pozzolana cement. It is a cost effective cement which I am going to discuss. The gypsum boards, which is a very good interior material which will give an aesthetic look inside the building. Lightweight beams, fiber reinforced cement concrete or cement components. Okay, that means inducing fiber, which I am going to discuss. And the very interesting part is FRP composites. See, nowadays in the engineering industry, okay, especially in the civil engineering industry, the advancements has happened in such a way that, okay, we have been moved from heavyweight to lightweight. For example, the stone is the heavier weight material, okay, which we are going to use for the construction in order to build a house or building, okay, and to that, okay, scenario, we have been moved to the, okay, that is FRP composite, that is fiber reinforced polymer. The fiber reinforced polymer is one of the lightweight material predominantly used in aeronautical industries or aerospace industries. Okay, there the aeronautical industry, the lightweight materials are predominantly used. So we have been moved from lightweight, okay, or heavyweight to the lightweight extents. Into this context, okay, that advancement has happened in the civil engineering. So that means in this particular module, you people are being exposed to the both conventional material and also alternative to that conventional material, that is alternative building material, so that we can attain the sustainable environment in turn that will contribute to the green building. So with this perspective, okay, we will move on. Next, as I discussed or stated in the slide, the different types of material. So these material are predominantly used in masonry. For example, if you consider a building, the building comprises of, okay, the components such as substructure and superstructure. Okay, the substructure is the foundation part, okay, and the superstructure comes with the wall, the slab, the column, all these things. Okay, so these material, that is stones, laterite blocks, burned bricks, clay blocks, all these blocks are predominantly used in the wall and also sometimes in the foundation part. So which I am going to highlight you today. Is it clear? So let us discuss one by one that various building material and their contribution with respect to the construction. So let me start with the first, stones. So we know that the stone is an essential and more prominent, or I can say building material in construction compared to other natural building material, because the stone is a majorly used building material which occupies more space in the building. Okay, as I highlighted, the stones will be used in both substructure and also in the superstructure. That means the stones will be used in foundation and also in the superstructure, maybe in the walls, something. Okay, so coming to the production process, how exactly we are going to get the stones? These stones are obtained from rocks. Okay, I think in the video 1 or in session 1, I have been showcased one of the photo of quarrying process. Okay, there you can see that, okay, these stones are being produced by, okay, that is the process of taking out stones from the natural rock bed, which is known as quarrying. So this is the process involved in the production of stones. That means by doing the quarrying process, as I mentioned, this quarrying, that means extraction of stones from the rock, will be done through blasting. By the blasting process, we are going to extract the stones from the rock, which is called as quarry. Okay, and these rocks majorly, okay, these rocks or this particular rock will be available in, okay, various forms, or we can use in construction. Starting with, okay, we can see that is maybe you people have been studied in your elementary classes, okay, regarding the rocks. That is the formation of rocks. How exactly these rocks are formed? Okay, before procuring the stones, we will discuss how exactly the rocks will be formed. Okay, these rocks will, or these stones will be broadly classified, or rocks will be broadly classified into three. That is igneous rocks, sedimentary rocks, metamorphic rocks. From these rocks, we are going to procure the stone. For example, okay, come back to the stones. That is the number 1, igneous rocks. How we are going to get the igneous rocks? So this is a natural phenomenon. That is the rocks we are going to get from the geothermal and weathering process. From these two processes, okay, weathering and heating, that is thermal process, these rocks will be procured. That is, these igneous rocks will be formed by cooling and solidification of molten magma, that is during the volcanic eruptions. During the volcanic eruptions, okay, that is cooling of molten magma, okay, these igneous rocks will be obtained. Okay, after obtaining the igneous rocks, there is especially these igneous rocks will be available in the earth crust, that is below the earth crust. Okay, and after obtaining these igneous rocks, due to the changes in the, okay, the atmospheric condition, that means maybe temperature variations, chemical variations, okay, the breakdown of rocks is going to happen. Okay, and this will be called as sedimentary. Next, metamorphic, okay, rock means the metamorphic rocks will be happen or will be occurred due to the heating and the variations in the temperatures. Okay, so these, like this, the various types of rocks will be formed. So coming to this, why are being discussed? Because in the construction, we are going to use a various types of stones. So these stones will be procured from the different types of rocks. Okay, so we need to know, okay, what exactly these stones are, why, okay, how exactly these stones are going to procure from those rocks. For example, you can see from igneous rocks, okay, in the igneous rocks, the predominant rocks are granite and basalt. See, the granite, whatever the commonly you people observe in the day-to-day life, that is aggregate, and the common language the people used to call jelly. So those particular material or stone will be procured from igneous rocks and is available as granite. So that is a granite material. Did you get my point? So it is a igneous rocks. Basalt is a igneous rocks, and next the sedimentary rocks is limestone. The limestone is the predominantly used material to manufacture the cement. And the sandstone, okay, in earlier days the sandstone and basalt were majorly used to construct the temples, okay, and mosques and so on. Okay, likewise metamorphic stones are gneiss and marble. So these two material also, as I explained, okay, the coarse aggregates will be available in the two forms. It may be available as igneous rocks in terms of granite, or it may be available as metamorphic rocks in terms of gneiss. Okay. Apart from this, marble, you people already know that it is a majorly used flooring material, okay, a predominantly used flooring material, okay, which will give an aesthetic look or appearance to the building. Okay. So these are the stones or types of stone that where we are going to procure from the rocks. So by doing the quarrying process from the igneous rocks, we are going to obtain the granite and the basalt, and from the sedimentary rocks we are going to obtain limestone and sandstone, and from the metamorphic stones we are going to obtain gneiss and marble. So various types of stones will be used in a different situation. Okay. The coarse aggregates, whatever you people see in the day-to-day life, are available as granite and gneiss. The marble will be used predominantly as flooring material, and this limestone will be predominantly used in the preparation of cement. Okay, with this we'll move on to the next. And this is the what exactly the process that is going to happen. You can see over there from the picture how exactly the quarrying process that has been happened. Okay, there the trucks or the dumpers, they are going to procure the stones, and preferably these stones are going to procure, and they are going to later chisel or dressed to the proper shape and size, which I am going to discuss in the next slide. Okay, because whatever the stones we are going to procure will not be in the proper shape and size. We need to make it to a proper shape and size, okay, in order to use it as a masonry material, or I can say for a wall material, okay, I need to use. So this is what the process of quarrying we can people see in the photo. Okay. Next. See, I have been explained in the last slide the various types of stone, that is granite, basalt, sandstone, limestone, and so on. So in this, which is the stone that is predominantly used and why it is used? For example, granite, as I told, is the predominantly used stone. Why? Why? Because that granite stone has got higher strength compared to other material or other stones. The granite has got higher strength, okay, compared to other stones. Okay. And the next, metamorphic rock, that is gneiss stands second, which will be used as a coarse aggregate. But as I mentioned over there, that is when these gneiss are loaded perpendicular to the grains, that means you people can see that when you hold a stone, it inside the rock or inside the stone, it may see several grains. Okay, that vertical grains. That vertical grains, that means if I load perpendicular to the grains, the gneiss will hold the lower strength. That means it doesn't have a more strength to bear the load. Is it clear? Next, coming to the sandstone and basalt, the sandstone and basalt are less durable material. That's why nowadays they are not that much preferred, and the availability are also decreased. Okay, you can see that the whole temples, in whole temples or mosques, you can people see that this sandstone and the basalt are predominantly used. And till today, many of the temples, mosques or church, till today it is standing after several 200 years. Okay, after several years I can say. Okay, that means nowadays it is becoming a less durable because of availability and the formation of rocks. Okay. So this is regarding a small introductory part about the stones. Okay. Next, once if I am going to use a stones, any stone, whether it is granite, whether it is basalt, whether it is sandstone, whether it is limestone or what, okay, from the next thing, that stone should possess certain requirements, characteristics or properties. Then only I can say whether it is a good stone or bad stone. So based on the requirements or the characteristics or the properties, I can say it is a good, bad or bad. So first one is structure. Okay, you can see that structure. The structure will be there in such a way that the structure of the stone should be easily dressed and suitable for superstructure. That means, dressed means I can chisel it, okay, through the wedges and all those things, through the hammer. I can make it to the required shape. I can make it to the required shape and form a required rectangular shape. So those things I can be easily dressed by seeing those structure. That is the first property or characteristic. Second thing is texture. So the fine grained stones with homogeneous distribution look attractive. That means I can use it for carving. Okay, that means, for example, in the front elevation of a building, I can create any good aesthetic view if the texture inside the stones contains homogeneous way. Okay, or homogeneous distribution I can say. That is the second thing stone should have. The next thing is density. This plays a very, very, very important role. For example, okay, if heavier dense stone is used, that means it is stronger. In turn, the strength will also be stronger. If lower density stone is used, automatically it is weaker and the strength will also be less. Hence, okay, if you want to go ahead with a more strength, we need to use a high density stones. Okay, if you go with a light density material, then we'll go with a lightweight stone. For example, if I want to quote the examples of stones here, less dense and high dense. High density is granite, as I mentioned, because the compressive strength or the strength, usually we measure the strength in terms of crushing or compression. That means applying the force on the stone. Okay, how much is the ability of a stone to resist without getting crushed? That is what we are going to measure. Without getting crushed, how much is the ability of a stone, okay, that will resist that particular load? That is what? Strength. So now granite has got a more strength. Okay, and coming to the low density material, the low density material or low density stone is pumice stone. The pumice stone is a low density material, okay, which will float on the water, okay. Because of this less density, okay, the strength will also be less, okay. And you can see that in the lightweight stones, why it is lightweight? Because of the presence of porous, okay. The porous things presence, okay, will indicate, okay, the light density automatically in turn will lead to the less strength. Is it clear? Next, appearance. A stone with uniform and attractive color is durable. If grains, that means it depends upon how exactly the grains are distributed inside. Okay, for example, marble. So marble and granite will give a very good appearance. For example, I want to mention the one point here. The granite is available in the two forms. One is granite can be used in the stone, and another form of granite is that can be also be used in flooring material. That can be used in a flooring material. That means the marble and granite will have a grains inside that which will be an homogeneous distribution in such a way that that will give a very good look in the flooring inside the building. Next, the strength, as I mentioned, strength is an important property one should look. That means if the density is more, the strength will also be more. The granite will attain the more strength compared to all other stones. Next, hardness. Okay, hardness is a very good or very important property one must look. That means We people used to walk on the flooring. Okay, when I'm going to walk on the flooring, okay, it will create some wear and tear because of the walking. So that particular wear and tear, a good stone should resist in a better way. Better the resistance, more will be the hardness. It is hard enough to resist the wear and tear. So this is what hardness. Next, percentage of wear, where I can say that the percentage of wear means without getting wear, that means without getting upbraided, I can say that the maximum allowed is lesser than 2%. It should not get wear more than 2%. Then I cannot say that it is a good stone. So a good stone, if I say a good stone, if I want to use that stone as a building material, these are the properties I need to look in order to use. So likewise, porosity, as I explained, if it contains more pores, it will absorb more water, automatically the density will be reduced, in turn it will reduce the strength. So better the pore should not be there, so that it will absorb less water. For example, granite, granite absorbs just 0.6% of water. The pumice stone, it will absorb more than 20 or 10% of water. So this is what the difference. Hence, the pumice stone got lesser density, granite stone got more density. So granite gives more strength, porous stone will give less strength. Okay. Next, weathering. Now, when the stones are subjected to various climatic conditions, maybe rain, wind and so on, that good stone should be there in such a way that when the stones are subjected to various weather conditions, it should perform in a better way. That's what they have been highlighted. The rain and wind cause loss of good appearance. Without losing the appearance, the stone should perform in a better way. That is what the weathering. Seasoning. The stone obtained from the quarry contain moisture. See, this seasoning will be done both in the case of wood and also in the case of stones. Why? Because seasoning means, why we need to seasoning means, there is a presence of, that means a moisture will be present inside the wood or inside the stone. Because of the presence of the moisture inside the stone or a wood, it will lead to the less durable and the performance will also be decreased. It will not perform better for several years or for a number of years. With respect to this, hence we need to remove those moisture from stones. So this is called seasoning. Removal of moisture from the stones is called seasoning. So these are all the properties one should look into that stones, or I can say a good building stone should possess. Next, so this is what a small table I have been highlighted. You can see over there I have been listed in the table the various types of stones and their corresponding strength as per PWD, that is Public Work Department. The Public Work Department has given the guidelines. What is the minimum compressive strength it should possess? And the next, for each material we are going to follow the bylaw, or I can say the codal provisions. We need to abide with the code. Whatever the building material we civil engineers use, we should abide with the code. If that material violates the code, we cannot use that material. That means this is the, what I can say, the testing pro forma, one stone should pass. If it passes these guidelines, then I can use that stones. Is it clear? So you can see that granite got 140 to 265 MPa in PWD handbook, and as per IS 65 to 228, like dolerite, limestone, sandstone, basalt, laterite, you can see the various stones. In that predominant is granite, and the next is, I can say, the basalt, sandstone, dolerite and so on. Even the gneiss stone also got a good compressive strength. So this is a small table which have been showcased, from their corresponding strength. Next, after coming to know about this application or uses of stones, as I highlighted, this can be used in various scenarios. One is substructure part, another one is superstructure part. Substructure part, we are going to use in foundation as a stone blocks. Okay, in the superstructures, we are going to use as a stone blocks in the wall. Okay, in the building walls, we can use it as a building material. So coming to the application, we can see the construction of ME and permanent structure, dam, any structures you can take, stones is a predominantly used construction material. Without stones, we cannot go ahead, which is a basic material or most dominant material where we are going to use. For example, if you take concrete, anything, road construction, highway construction, airport construction, building construction, anything you can take, dam construction, a stone is a very essential material. One must look into that material. So that's what I've been highlighted. Dams, docks, harbors, lighthouse, abutments, piers, bridges, buildings, whatever the thing, any structure I can say, stones is essential and it is compulsory, it is required. So that is building work in hill areas, whatever the thing, aggregates for concrete, slabs for paving, and railway tracks, ballast. Here you can see that rails or railway track that will be resting on that ballast. That ballast is also a stones. Okay, that is a foundation. It will act as a foundation to the rails. Okay, so this is regarding the uses of stones. So I hope I have been clear regarding the stones. So we will move on to the next. Okay, the building material, okay, which will be used is laterite blocks. Okay, laterite blocks. I think you people have been observed these types of blocks in majorly coastal areas. Okay, majorly in coastal areas. Okay, you people can never come across, especially in this scenario, this type of laterite blocks will be observed in the coastal areas. Let us look into this, what exactly is laterite blocks and how exactly it will be formed and its performance. Okay, lateritic blocks are obtained from lateritic soil. Okay, the lateritic blocks are obtained from laterite or lateritic soil. This lateritic soil is predominantly available in coastal areas. Did you get my point? So from this lateritic soil, we are going to manufacture the laterite blocks. Now, this laterite blocks, okay, that will be formed, as I mentioned, where the annual rainfall, I can say, which is very high, and the atmospheric temperature varies. Where the atmospheric temperature varies with high annual rainfall, okay, this, okay, laterization, or I can say lateritic soil will be formed. Okay, that means this lateritic soil will be formed in such a way that, okay, this lateritic soil will be formed by the process of laterization. This laterization process is going to happen in the atmospheric variations. That is where exactly the high annual rainfall is there. So let us know that what exactly is the process of laterization. Okay, why? Because you can see that on the surface, you can see the laterite blocks because I've been put two photos. Okay, one is the photo where you can see from the far, and another photo you can see that, or another picture you can see that, okay, some small pores are there. You can see that. Okay, see, this process of laterization is going to happen, okay, in such a way that, okay, that hollow spaces you can see or observe on the surface. Why? Because during this lateritic soil is a very soft soil, okay, and this lateritic soil during heavier rainfall, okay, what is going to happen is this lateritic soil comprises of silica, alumina and iron. When the annual rain, that means the rainfall happens or occurs, the rainfall, higher rainfall, what is going to happen here is make the silica particles to elevate inside the lower zone. Okay, this rainfall will make the silica particles to elevate into the lowermost zone. That means it will be settled at the bottommost pole. Okay, leaving only iron and alumina on the topmost zone. Is it clear? Whatever the pore space that will be left out on the top, where you can see from the picture, so that portion will be silica detached and elevate into the lower zone. So that is what you can see over here. Is it clear? Okay, so this is what the process of laterization, that pore space where it will be left, you can observe on the surface is, okay, the silica detached particles that is going to settle into the bottom. And this lateritic rock usually can be treated as a very weak rock. Why? Because the soil is very soft, and during a rainfall it will become very softened. The very interesting thing about the lateritic block is, when the heavy rainfall is happen, okay, the lateritic soil is so softened, okay, that can be cut into required shape, or it will be so soft. During sunny day, okay, it will be so hard enough, okay, that means it will be formed like a rock. So that is what the very interesting factor about that lateritic block. That's why what they are going to do is, during the rainy season, okay, that means this particular lateritic soil, they are going to cut it, okay, to the required shape and sizes, and they are going to allow it to the drying during the sunny day or during the sunny time or summer time, so that whatever the softened soil or softened block was there during rainy, once it is exposed to the, okay, the sunny, okay, or sun, automatically this lateritic block which was cut into required shape will become hard, okay, to bear the required amount of load. So that is what the interesting factor about lateritic block. Is it clear? Okay. So hence one must look into this aspect about the lateritic block. So this is what a very interesting factor about lateritic block. Okay, and that's why, as I've been told, that these lateritic blocks are available only in the coastal part. Why? Because the lateritic soil is available or locally available in coastal areas. Okay, and this is about the lateritic blocks. So coming to the next slide, that is sizes. Okay, as I mentioned, during the rainfall, they are going to cut it to required shape and sizes. So this is what the shape and sizes they are going to cut. And you can see the lateritic blocks also will be cut into the standard size as per IS 3620. So this is the codal provision I should abide while manufacturing the lateritic blocks. Okay, those size are: length is 390 millimeter, breadth is 190 millimeter, thickness is 190 millimeter. Length, breadth and thickness. It is also can be produced into bigger sizes, that is 490, 190, 190, 590, 290, 290. Likewise, you can produce the standard size of a lateritic blocks. Okay, and this particular size, they are going to cut it, and they are going to allow it to dry during summer. Okay, and another very important thing is, the lateritic block doesn't demand any burning. No burning is done. Just cut it to the required shape and sizes during rainy season and allow it to dry during summer. Okay, no burning is required. Okay, this is what the production process of lateritic blocks. Next, what are the qualities or the properties it should possess or characteristics it should possess? Okay, as per IS 3620, lateritic blocks, okay, should absorb a water, okay, not more than 12% by mass. It should not absorb more than 12% by mass. If it absorbs more, it will become less dense. Automatically, the strength will also be reduced. Okay, that's why we need to be very careful in this. And then the specific gravity. Okay, specific gravity means it is defined as the ratio of weight of the substance to the weight of the equal volume of water at standard temperature. Okay, or I can say liquid, weight of equal. Why I am specifying liquid? Because one material will be performed with the water and some other material will be performed with the various things. That depends upon the dilute. For example, cement specific gravity will not be found out by water. Okay, it will be found out by kerosene. Likewise, the coarse aggregates, okay, specific gravity will be found out by water. That means it should not be reactant. That means it should not get react. Okay, if I mix cement and water, it will react. That's why we need to perform with kerosene. Okay, that is what the definition. The specific gravity is defined as the ratio of weight of the material or sample to the weight of equal volume of water at standard temperature. That is what specific gravity. That specific gravity should not be lesser than 2.5. Next, strength, which is the predominant factor, one must look into that. Okay, as I mentioned, any material we are going to use as a blocks or a bricks in the wall. I will repeat, any material we are going to use as a blocks or a bricks, whether it is any block or any brick, any material it may be. When you are going to use as a wall material, that particular material should possess a minimum compressive strength of 3 megapascal or 3.5 Newton per millimeter square. Did you get my point? This is the compressive strength or strength it should possess. If it possesses lesser than this, then I cannot use that lateritic block. Okay. So these are the properties one must look into this. Okay, and coming to the application wise, okay, the application wise, so these lateritic blocks, as I mentioned, okay, this will be used as a superstructure, predominantly used as a superstructure, okay, in wall component, okay, in between the columns, okay, in between the column, these lateritic blocks can be used as a wall material or in order to construct a wall. Okay, and this, as I mentioned, this material is predominantly used in coastal areas. Is it clear? Next, we will move on to the next material, that is bricks. So I think you people are in the day-to-day life have been observed this construction material. This is a predominantly used material. So let me define the bricks. The bricks are obtained by molding clay in the rectangular blocks of uniform size and then drying, okay, and so on. That means, okay, the soil, from the clay soil or from the soil, we are going to manufacture the product to a required shape and a size, so that will be called as bricks. And there will be so many names for this: burnt bricks, burnt clay bricks and all. Okay, that means clay is the predominant okay, material in order to manufacture a bricks, and apart from this, okay, this clay or a soil, okay, material is going to burn after producing to the required shape and size. Why the necessity of burning is required, which I am going to highlight next. Okay, so there you can see the bricks. Next, what are the composition? This composition plays a very, very important role. A good bricks should possess so and so composition. For example, I will start with alumina. Okay, alumina inside the brick, okay, should contain 20 to 30%. What exactly this alumina influence or function? What is the function of alumina? This alumina presence of 20 to 30% will impart plasticity to the bricks. It will impart plasticity. That means I can mold it to any shape and size. If I want any shape, if I want rectangular shape, I can mold it. If I want a square shape, I can mold it. If I want to any shape. So that plasticity nature will be obtained inside the brick only because of the presence of alumina. Okay. Next, silica. Okay. The silica, presence of silica in a brick is 50 to 60%. Okay. This silica presence, okay, will impart a very good strength in the brick. Okay, as I mentioned, 3.5 MPa. That 3.5 MPa because of silica. Okay, and it will not allow any crack to happen. Okay, shrinkage. I hope you know shrinkage. The shrinkage means change in the volume of a bricks. That is expansion and contraction. If there is any change in the volume, for example, whatever the required size and shape have been manufactured, okay, due to the exposed to the various condition, climatic condition, if it is expands or contract, that means change in volume. So that is called shrinkage. So those change in volume will not take place because of the presence of silica. Warping, warping means unevenness. Okay, the bricks you can observe is very flat only because of silica. Next, okay, that means the shape, because the very good shape that can be observed, the strength, okay, all those things can be observed because of the silica. Next, lime. Okay, the limes, there will be limitation while that will be there inside the soil. Okay, if it exceeds, it is dangerous. Okay, that is the lime should be present inside the brick, preferably 5%. Okay, and it will be present in the fine powder state. Okay, if it is more, okay, it will lead to the efflorescence problem. That means white patches that can be observed. That's why we need to limit the lime content. Next is iron oxides. The iron oxide present will be 5 to 6%. Okay, are desirable, and this iron, why the brick looks red? Why the brick looks red? Because of iron. This iron will impart color to the bricks. The iron will impart color to the bricks. Okay, coming to the magnesia. Okay, a small quantity of magnesia in the brick imparts yellow tint into the bricks and decrease shrinkage. If there is any, we need to be very cautious. As I told, if there is more magnesia, more lime content, okay, it will be the root cause for shrinkage or warping. So hence, we need to limit the magnesium. That means the decay of a bricks is going to happen if there is any excess lime and magnesia. Is it clear? So this is the influence of various chemicals inside the soil or clay soil, so that I can manufacture the bricks. Next, what are the, I can say the classification, or I can say bricks can be classified into various types. Okay, that is unburnt or sun-dried bricks. That means if I am going to manufacture, okay, without any burning, the bricks, that is called unburnt or sun-dried. That means no burning has been done. Okay, and another part is burnt bricks. The burnt bricks will be first class, second class, third class, fourth class. Why I have been specified first class, second? That means first class will abide with properly with the code. It is more strength compared to the second, third and fourth class. Likewise, second class will be little lesser compared to the first class in the performance wise, but more with respect to the second class and third class. Sorry, third class and fourth class. Likewise, third class, okay, will be lesser compared to the first and second, but more with respect to the fourth class. Okay, like fourth class is the, that means it is not so good in the properties. This classification will be done based upon the properties, based upon the strength, based upon the performance, based upon the shape and all. Is it clear? And apart from this, the IS also classifies the bricks into two types. One is modular bricks, another one is non-modular bricks. Okay, modular bricks and non-modular bricks. Okay, so this is the way the IS has been classified. And you can see over there in the photo next, okay, I have been showcased how exactly the various forms of bricks look. You can see the country bricks, or I can say fourth class or third class bricks looks. You can see the white patches on the surface. That is what I can say, the uneven shape, okay, the less performed bricks, how exactly it looks. And you can see other two bricks are first class and second class. Okay, and also have been specified based upon the manufacture. Okay, I can say the molded bricks and wire cut bricks, which I am going to discuss next. Okay, that is table molded and wire cut bricks. Okay, this is another classification I can do. One is, okay, that is unburnt and burnt bricks. Another one is modular and non-modular. And another one is country bricks, molded bricks and wire cut bricks. That means the classification based upon the performance. Okay, here the classification based upon the manufacturing process. Okay, based upon the manufacturing process, I can classify it into, okay, the country bricks, table molded bricks and wire cut bricks. And you can see the clay percentage inside that bricks. Clay bricks, that is country bricks, okay, 18 to 20, table molded 25 to 20, okay, 20, 30. Next, wire cut bricks got 40 to 45. That is the presence of, okay, the clay content. And coming to the manufacturing process, how exactly this manufacturing will be done. You can see the two photos over there. One is, that is the kiln or the furnace, okay, where the bricks will be burnt and manufactured. And another photo you can see, that is the bricks will be also manufactured through the machine. Okay, the two scenario have been showcased, okay, which I am going to highlight. So this is what the next slide, that is the manufacturing process which I am going to do. Okay, that is first preparation of soil, that means selection of soil. Okay, before doing any production process of bricks, the soil selection is very important. So how we need to prepare the soil? Okay, that is in the preparation, first remove the topsoil. What is that remove? Removal of topsoil. The removal of topsoil means, okay, the soil in which you are going to manufacture the clay bricks, in that up to depth of 200 millimeter or 20 centimeter, we need to take out the soil. Okay, the topsoil will not be preferred to manufacture the bricks. Why? Because it contains lot of impurities. Okay, those impurities will not be good for manufacturing of bricks. Okay, hence what I want to say here is remove the top surface of a soil up to a depth of 200 mm. That is what removal of topsoil. Next, digging and spreading. After removal of topsoil, okay, the beyond 200 mm, okay, those soil will be preferred which will be spread uniformly, okay, spread uniformly in order to prepare the bricks. That is what digging and spreading. Next, the third preparation is cleaning. That means if that soil contain anything like vegetable matters, any deleterious substances, anything, if there is any lumps and so on, so those things need to be removed. That is what cleaning. Weathering. Weathering means after cleaning, okay, after spreading and all those things, removal of those things, the soil, okay, which will be used for manufacturing of bricks will be exposed to the atmosphere in such a way that by exposing the soil to the various weather condition, okay, those weathering will in turn, okay, lead to the dense and good strength, okay, bricks. That's why we need to expose the soil to the atmospheric condition for certain number of days. Next, blending. Okay, blending of clay soil with some other components. That's what that is alternative material says. Okay, for example, instead of using 1 kg of completely clay soil, okay, 1 kg of completely clay soil, why can't we blend with, okay, a waste material? That means, what I can say that the factory produces various amount of waste. Okay, replace some amount of clay soil with respect to this waste. That means, before replacing, we need to first test the waste material, whether it can be replaced or not. That is very important. Okay, that also I am going to talk in the next slides. Okay, see, once if we search for any alternative building material in order to replace the natural material, that performance of alternative building materials is very important. Simply we cannot replace anything. Okay, after replacing it should perform better. That is very important. Okay, so hence blending can be done. Next, tempering. Okay, that is kneading. Okay, all those things, that is called tempering. So these things are required in the first step, that is preparation of soil. So after preparing the soil, then, okay, molding of bricks. Okay, this molding can be done in two ways. As I mentioned, hand molding and machine molding. The two ways I can go in. If you want a better perform bricks, go for a machine molding with a mechanized process. Okay, if hand molding is done, okay, the required shape and size cannot be achieved properly sometimes. Okay, and also density and strength may vary compared to the, okay, the machine molding. So that's why you can see the ground molding and table molding. Okay, so the ground molding means where we are going to prepare the, okay, the bricks in the ground. Okay, table molding means where you can see from the photo, this is what hand molded and table molded. Okay, hand molded and table molded bricks you can see over there. Okay, next, machine molding means plastic method and dry method. That means mixing it, okay, with the mechanized process and taking out the the bricks. That is called machine molding. And why we prefer machine molding? Because we can increase the density by reducing the voids. Voids means the pore spaces present between the soil particles. If there is more space or more voids are present, density will be reduced. In turn, strength will be reduced. In order to overcome this, machine molding is more preferred so that we can achieve better density and more strength. Next, drying. Okay, drying is natural drying and artificial drying. That means after preparing the mold, okay, that means bricks, we are going to allow the bricks to get dry. Naturally means exposing to the sun. Artificial drying means, okay, we are going to dry it in some oven or whatever the material. Okay, that is what drying. Next, burning. Burning is a very, very important component which is a process, okay, very important process we need to look at. Because burning is the only thing that will produce a very good strength burnt clay bricks or bricks. Without burning, we cannot produce a clay brick. Where? Because that alumina particles will be ignited so that it will impart a very good performance. Did you get my point? So the burning is very much essential, okay, and this burning process they are going to burn it in a intermediate kiln and also the continuous. These are the kiln they are going to use it. Okay, nowadays some of the things, okay, they are going to cut the, that means construct the brick furnaces. In the brick furnaces they are going to stock, there can see that I have been showcased on the photo. In the bottom, the coal they are going to use it, okay, and they are going to burn it for several number of days. That is also one thing. Okay, controlled burning and uncontrolled burning. Controlled burning means we are going to burn it in a kiln, and uncontrolled burning means without burning in any kiln. Okay, that means simply putting the or igniting the fire to the coal at the bottom, okay, and allow the bricks to get burned, okay, for so many number of days. No control is there. Okay, controlled burning means to a particular temperature, say that is 600 degree, 1000 degree and so on. So to this temperature I am going to burn it through intermittent kiln or continuous kiln, okay, so that will be the burning process. Is it clear? And another important thing is we need to be very cautious. That means this overburning that is going to happen. This overburning that will come into the picture while burning in the brick furnaces. Okay, when you go into burn brick, okay, that is called overburned bricks. What is going to happen if the brick is overburned? If there is no control in the furnace, that overburned bricks will not be suitable for construction. Why? Because that overburnt will be, okay, lead to the blackish, convert the color from reddish to blackish, where the density and strength will not be that much good. So that's why, okay, we should not prefer overburnt bricks for construction process. Is it clear? So this is what I have been showcased, that is manufacturing methods, hand molded, table molded and all. So next, as I stated in stones and lateritic blocks, here also we need to look into the characteristics or properties of requirements of bricks. Okay, a brick should possess, okay, important characteristics as per IS 1076. As I mentioned, okay, 1076. So this is the codal provision I am going to use. For example, first dimension and tolerance, you can see that modular sizes and non-modular sizes, that is one of the classification. The code has given 190 by 90 by 90, that is modular, and non-modular is, okay, 230 by 110 by 70. Okay, so this is the brick size we are going to use, okay, in the manufacturing of bricks. Okay, that is 230 by 110 by 70 and all. For modular bricks, if you go into add the 10 mm mortar, okay, that means if you're going to add a mortar means that composition of cement and sand, okay, that is going to place above the bricks in order to construct the wall. That is an adhesive agent or material. Did you get my point? So which will be act between the bricks. So those mortar, if I am going to lay it, so then the 10 mm thickness will be increased. That is 200 by what I can say 20, okay, 100 by 100. That is a modular brick, and non-modular brick is 230 by 110 by 70. So this is the dimension. And the compressive strength, as I mentioned in lateritic blocks, the same strength holds good here also. It should not be lesser than 3.5 MPa or 3.5 Newton per millimeter square. Is it clear? Next, water absorption value. The water absorption value should not exceed more than 20% by weight. So this is another property. And efflorescence, okay, as I stated, you can observe white patches. This efflorescence problem is predominant. Now I want to quote a very interesting thing here. Why we will not prefer the clay bricks in the coastal region? Because this is the reason. Once the clay bricks are exposed to the outside environment, because of the presence of salts in the coastal area, the bricks has a tendency to absorb those moisture. Once the, okay, if moisture contains a salt which will be absorbed by the bricks, it will lead to the white patches, that is called efflorescence. Those efflorescence can be visualized in various forms. Okay, it may be no efflorescence, slight efflorescence, moderate efflorescence, heavy efflorescence, and serious efflorescence. I think in one of the photos I have been showcased, there is country brick, that white, complete white, that means completely convert from red color to white color. It is a very serious problem. Okay, that means the durability is not good. Okay, automatically the strength and all, the performance is very bad. Okay. Likewise, aesthetic appearance, okay, it gives a pleasant color. Next, porosity, as I stated, is a very important characteristics of a brick. Okay, especially this porosity can be minimized by machine molding. So machine molding, okay, will do. And another thing is sometimes in the bricks they are also going to perform the initial rate of water absorption. That means water absorption will be done for 24 hours. Okay, within an hour how much the bricks can absorb the water, that can also be visualized. Next, fire resistance. Okay, the brick is an excellent fire resistant because it is comprised of majorly soil. That's why it is better fire resistance. And you can see that 100 mm brick wall with normal plastering, okay, that is 12.5 thickness plastering, can resist up to 2 hours, which is quite good. And a 200 mm non-plastered brick which can have a maximum rating of 6 hours. That means because it contains a soil, okay, it is a better resistance to the fire. Next, wear resistance, okay, is another property. I need to look into that. Okay, that depends upon the bonding and all. Okay, so this is regarding the properties, one should look into this. Okay, so by possessing these characteristics or properties, I can say the brick is good. Next, advantages. Coming to the advantages are it is economical because raw materials are easily available. Okay, no need of worrying. And even also the burning is very simple. If you are not going for machine molding, just place, okay, ignite the fire in the coal and we can burn it. So hard and durable, okay, that is second advantage. Compressive strength is good. Different orientation and size give different surface structure. We can orient to different, that means, okay, if you orient in a zigzag fashion, we can create a different aesthetic view. If you're going to construct in horizontal fashion, if you're going to give a different view. Okay, very low maintenance cost. Okay, demolishing of brick structure is very easy. Okay, no need of heavier equipments, you can demolish very easily. Reusable and recyclable. Okay, that means brick can be replaced, that means we can reuse it. Okay, and we can recycle. Okay, recycle and we can reuse it. Okay, higher fire resistant, as I stated, the fire resistance is very high. Coming to the disadvantages, what are the disadvantages of clay bricks? Next, the disadvantages are uneven shape. That means without producing to the proper shape, okay, that means if you're not going to manufacture properly, the shape will not be even. That means the edges will not be even, that will be uneven. Next, labor intensive. That means heavy labor is required. Okay, one is for preparation of the brick. Okay, a kiln is required to burn it. Okay, cutting of agriculture, that means agricultural land and all those things is required. Time consuming, that means we need to expose it, we need to dry it, we need to burn it. Okay, it is a tedious, okay, the time consuming process. Cannot be used in high seismic zones. Okay, in the high seismic zones we cannot use this material. Okay, since bricks absorb more water easily, that's what I have been told. Efflorescence, okay, that is not fluorescence, it is efflorescence. Okay, efflorescence can be observed. Very less tensile strength. Okay, rough surface of the brick may cause, okay, that means mold growth. Okay, cleaning brick surface is a hard job. Okay, so these are the disadvantages we can observe. I hope I have been clarified regarding the bricks or burnt bricks or clay bricks. Okay, is it clear? Now, the next, okay, which I am going to discuss is, okay, hollow clay blocks. This material is not there in your syllabus, but this is predominantly used in a building material. So I wanted to discuss some of the aspects. So that's why. Okay, so next is hollow clay blocks. Hollow clay blocks is nothing but this is also produced using clay soil, but the change here is, okay, the burnt bricks and the hollow clay blocks or burnt clay bricks and hollow clay blocks is there it is a completely solid material, but here I will be induced hollowness inside the brick. That's what is called hollow clay brick. That means pores. So let me know that. Okay. So I am going to define the hollowness, how exactly we are going to call hollow clay blocks as per the IS. So a block having one or more large holes or cavities which either pass through the block or do not effectively pass through the block and having a solid between 50 to 75% of the total volume of the brick, okay, is called hollow clay blocks. That means that solid block contains perforations and hollowness throughout the block. I think you can see from the left picture how exactly it looks, the hollowness. You can see, okay, 1, 2, 3, 4, 5, 6, 7, 8. That means 12 number of hollowness are there. You can see from the first picture. Okay, so that is what hollowness. Those hollowness may extend throughout the length of the brick or they may stop at the partial length. So that is what the thing. That is one thing. And next, if I want to say hollow brick, that means if the solid content is, okay, less than 50%, I can say that it is a hollow. That means the total volume of a brick, okay, what I can say the percentage is 50 to 75%, then I can say it is a hollow clay block. So this is what the definition. I think you can see the construction process. And nowadays these hollow clay blocks predominantly they are using. Why? Because if you want to reduce the density of a building, for example, if people have constructed the ground floor and if you want to construct a one more floor, okay, where the people used to go with the hollow clay blocks. Why? Because if it is a very old building, the ground floor wall doesn't have a capacity to bear the load. At that particular instance, these hollow clay blocks will help you out, okay, to reduce the load of the building so that, okay, it will be no damage to the building. So this is what the hollow clay block codal provision, that is IS 3952 clearly specified type A, type B, type C, okay, various types are there. Okay, you can see that. So that depends upon the facing, and you can see the length, width and height, 190 by 90 by 90, 290 by 90. That means, and compared to the clay bricks, that is burnt clay bricks, the hollow size clay blocks length will be little bit, okay, more. Okay, hollow size clay block length little bit more. You can see the 290 by 90 by 90, 290 by 140 by 90. So like that. So coming to the characteristics, okay, as per IS 3952, this is the codal provision I am going to look for hollow clay blocks. So the dimensions are 290 by and so. Okay, the compressive strength you can see once again the same thing, whether it is hollow clay block or whether it is solid block, the hollow clay block also should possess, okay, the minimum of 3.5 MPa. Lesser than 3.5 feet possess, I cannot use that, okay, hollow clay block. Next is water absorption, the same thing, because it is also a clay material, hence the water absorption should not be more than 20%. Once again, efflorescence, okay, the efflorescence should not be more than slide. Okay, that is the one more important thing. If it is more than slide, we cannot use that hollow clay block. Next, these block usually have a bulk density. Okay, the density of this block is 950 to 1200. Normal clay brick density is 1800 kg per meter. Did you get my point? So that means the hollow clay block density is lesser. Okay, and these hollow clay blocks, as I mentioned, will be more preferred in order to reduce the load of the building where the earthquake cannot take place or where we need to resist the lateral loads. Next, okay, so this is the application wise, as I mentioned. Okay, when you go with one more floor, that means already ground floor is existing. If you want to construct one more floor, we can go ahead with the these hollow clay blocks. Nowadays, I think more houses, they are going with these hollow clay blocks. And another important, interesting thing is, it doesn't demand any plastering, because it is a smooth finished, machine molded and manufactured in the industries. Okay, it cannot be manufactured in any way. So that's why the finishing is very smooth, no need of plastering. So there is no demand of plastering. Is it clear? And hollow clay block, okay, that can be used, as I stated, as a load bearing unit. Okay, so load bearing unit, that means it can be used in the wall component. Okay, where the building wall is going to be constructed, at that wall we can construct with the help of hollow clay blocks. I hope it has been clear. Okay, so this is regarding, okay, the materials. Okay, today I have been discussed, okay, the stones, then I have been discussed the lateritic blocks, then I have been discussed the burnt bricks and hollow clay blocks. And all the four materials, please remember, it is a conventional building materials. Conventional building materials, and all these materials are predominantly used material in order to construct a wall in the buildings. Okay, likewise, okay, in the next video we will discuss some more types of blocks, that is concrete blocks and so on, like alternative blocks, material blocks and so on, in the next session of it. Hope this session has given, okay, an insight to the blocks, okay, how exactly it looks and what exactly the characteristics, properties, okay, one must look into that bricks or blocks. Okay, with this I am going to end this session. Thank you.